Yes, so hi everyone. So welcome to my channel Easy Tech Masters. Today I would like to explain how to draw impedance or reactance diagram of given power system. So before going to that, we must know these definitions because the values which we are going to represent that must be in the per unit. So these formulas will be very much useful while we are drawing the impedance or reactance diagram. And the first one is, what is per unit value? Per unit value is the ratio of actual value to the base value. And the second one is, what is the percentage of per unit value? It is the same thing, actual value by base value into 100. And third one is, what is base impedance? Base impedance is, it is the ratio of the square of kV base, kilovolts base, that is the voltage in kilovolts, to the MVA base, the power rating. Next. And the fourth one is, what is Z per unit new? Because in some cases we need to change the base values of the element. So in that case, this formula is very much useful, which is given by Z per unit new is equal to Z per unit old into kV base old by kV base new whole square, that is multiplied by MVA base new divided by MVA base old. And the last one is, so we must know about this formula also regarding to the transformer. Transformer, that is kV base on LT section of transformer is equal to kV base on HT section of transformer, that is multiplied by LT voltage rating by HT voltage rating. And we must know that the per unit impedance or per unit reactance of the transformer referred to primary is equal to referred to secondary, that is Z per unit of transformer referred to primary, that is 0, 1, is equal to Z per unit of transformer referred to secondary. These formulas we must know before drawing the impedance or reactance diagram. So now I would like to explain this, how to draw the reactance diagram with one example. Let us see the example. This is the example that they have given. To see this, so the problem is like this. A 300 MVA 20 kV three-phase generator has a sub-transient reactance of 20%. That means reactance is 0.2 per unit. This is of the generator. The generator supplies two synchronous motors. The two synchronous motors, these are the load of the given system through a 64 kilometers transmission line. Transmission line length is 64 kilometers, having transformer at both ends as shown in figure. The figure he has given like this. This is the figure. Here you can observe that this is the generator and these two are the motors and these two are the transformers, and this is the transmission line. The length of the transmission line is 64 kilometers as he has given. And later on he said that in this T1 is the three-phase transformer and T2 is made up of three single-phase transformers. That means this second transformer is made up of three single-phase transformer. Okay, next. The rating is 100 MVA, 127 by 132 kilovolts, 10% reactance. Yes, about this one. The series reactance of transmission line is 0.5 ohms per kilometer. That is, this 0.5 ohms per kilometer. This is per kilometer. We need to calculate for 64 kilometers. That is 0.5 multiplied by 64. How much we will get? We will put the same value here. Draw the reactance diagram with all reactances marked in per unit and select the generator rating as base value. Yes, this is the problem we have. Now, how to solve this problem? Yeah, the first, how to solve this problem in the sense. So, how many elements are here? First, now let us check. Generator is one. This is second one. And third one is transmission line. Fourth one is second transformer. Fifth one is motor 1. And the sixth one is motor 2, like this. For 6 elements or for 6 components in this power systems, we need to calculate the per unit impedance or per unit reactance. How to calculate the per unit impedance or per unit reactance? As we know these formulas, that is, the per unit value is equal to actual value by base value, and percentage of per unit value is equal to actual value by base value into 100, and base impedance is this, and especially we need these two formulas. Yes, we need these two formulas. Yes, what is this formula? Z per unit nu is equal to Z per unit volt into kV base volt divided by kV base nu MVA base whole square, and that is multiplied by MVA base nu by MVA base volt. And kVb on LT side is equal to kVb on HT side, that is multiplied by LT voltage rating divided by HT voltage. So these are the formulas we know. Now, how to solve this problem? Yeah, first let us see this question and we solve step by step. Yeah, the first one is, I will take the generator. He said that select the generator rating as base value. So therefore, let me assume solution for generator. Yes, whatever it may be, the new base kVA and new base MVA will be MVA base comma new. This is equal to 300 MVA. That is for the generator. Next, kV base new is equal to 20 kV. And you know that for this generator, he has given the same value. That means we are taking the generator ratings as the base values. Therefore, MVA base old is equal to 300 only, and kV base old is also 20 only. And he said that percentage of impedance, that is Z per unit, or reactance of the transformer, reactance of the generator, Xg is equal to Xg volt is equal to 0.2, because he said that it is 20%. So hence I used to take it as the 0.2. He said that this is the 20% like. Now what is the formula I know? Xg new is equal to Xg old. For all these things we need to use the same formula. Xg new is equal to Xg old, and the formula is like this. Yeah, what is the formula? Xg old, kV base old by kV base new whole square into MVA base new by MVA base old. Therefore, old into next kVb old by kVb new, this is whole square into MVAB new by MVAB old, like this. But here Xg new is equal to, he has given Xg old is 0.2. Next, I hope it is visible to you. KVB old is 20. KVB new is also 20 whole square multiplied by MVAB new is 300. MVAB old is also 300, like this. And finally, I will get 0.2 only. 0.1. So that is the first component. For the first component, I found this per unit value. Next, what is the second component? Second component is, just let us see the diagram once again. Here the second component is transformer T2. What is the rating of this transformer? The rating of the transformer I am going to find on the primary side. Primary side is, here it is LV side, 20 by 230 kV. Therefore it is LV side. So hence I used to take KVB old. This is for transformer. This is for transformer 1. KVB old is equal to 20 and MVAB old, this is equal to 350. Now I am going to take, and X per unit, XT old is equal to, he said 10%. 10% in the sense 0.1 lakh. Now I am going to use the same formula. That means for these base values, I am taking the new base as 320 kV. So hence kV base new is equal to 20 only, but MVA base new is equal to 300 only. Okay, so now I will use the same formula. Therefore, XT1 new is equal to, XT1 new is equal, what is the formula? XT1 old. XT1 old is 0.1 into KV base old by KV base new. That is, KV base old is 20, KV base new is 20 whole square, that is multiplied by MVA base new 300 divided by MVA base old 350. Okay, so then I will get the value like this. That is 0.1 into 1, because this will be cancelled. This is 1 into 300 by 350. So this value comes like this. That is 0.0857 per unit. It is better to take at least 3 to 4 digits after the point to get some exact value. Okay, this is for transformer 1. Second element, second component is over. Next, third component is transmission line. How to find out the transmission line? He said that the transmission line impedance or reactance is 0.5 ohms per kilometer. Now, what is the length of the transmission line? 64 kilometers. So, hence, I will take like this. Third one is transmission line. Transmission line. And for this, X per unit old is equal to, X per unit old is equal to, here I don't know what is X per unit old. So now I need to find out X per unit old as well as X per unit new also. So how I can find? In the sense, he said that actual impedance, that is XTL actual, is equal to J 0.5. This is per kilometer. If I multiply with this 64, then I will get as J 0.5 into 64. This is equal to 0.5 into 64. So which is given by 32. J32 ohms. J32 ohms. But I don't want this J32 ohms. I want in per unit value. How I will get per unit value? I know that x per unit is equal to actual value by base value. So this is actual value. Now what is the base value? In order to find the base value, again let us see. This base 20 kilovolts base is 20 kilovolts base is, so till this section, that is from generator to the primary winding of the transformer. But on the secondary winding, this voltage may be changes. How it is changes? We need to use this formula. What is that formula? Which formula you can use? This. KVB on LT section is equal to KVB on HT section into LT voltage by HT voltage. That means KVB on HT is equal to KVB on LT into HT voltage by LT voltage. So therefore, I will use the same formula like this. That is KVB on, so which side transmission line is connected? The transmission line is connected secondary side. Secondary side in the sense 230 volts side. So therefore, KVB on HT is equal to KVB on LT into HT by LT like this. Okay. Now what is the KVB on LT side? On the LT side, yes, just to see here. On the LT side, this base value kV base is 20 kV only. Okay, so I will take the same 20 that multiplied by HT rating of the transformer is 230, LT rating is 20. Now what is this value? Calculate this. I will get like this 20 into 230 by 20. So which will give 230 only. Yeah, 230 only. Now what is MVA rating of the transformer? This is my new, that is the KVB of transmission line. KVB I can take new is equal to 230. Okay. Next, what is MVA? MVA cannot be changed. MVAB is equal to the same value. What is that value? 300 only. I have the actual value. Now I want to find out the base value. What is base? XTL base is equal to, yes, what is the formula? KVB whole square by MVAB. KVB whole square. KVB whole square in the sense 230 square by 300. Then it will become 230 square by 300. This is 176.33 ohms like this. So I have XTL base and XTL actual. Now I can find out the per unit of the transmission line. How I can find? XTL per unit is equal to XTL by XTL base. That is actual value by base value. Here the actual value is J32 and the base value is 176.33. So hence this will become 32 by 176.33. So which is around 0.18147. Let me take 1815. This is per unit value of the transmission line. So that means I found the third one also. This is also over. Transmission line is over. Next I want to find the per unit reactance of the transformer. That is second transformer. Here one small thing we need to observe. What is that small thing? In the sense, this transformer is made up of, see that this second transformer is made up of 3 single phase transformers. Therefore, this rating is 300 MVA. Let me see, take transformer 2. Yeah, so MVA base new is old is equal to 3 into 100. Therefore, it is 300 only. 300 only. Next, KV base. Old is equal. Actually, just you can see this. 127 volts is the phase voltage. That means he has given the 3 single phase transformers are connected as a 3-phase transformer. Therefore, I can say this 127 kilovolts is the tell me, 127 kilovolts is the phase voltage. Now I want to find out the line voltage. Don't forget that for the transformer or whatever it may be, for the 3-phase section I used to take line values for solving entire problem. So hence 127 is the phase and it is the star. Then what is the line? The line will be VL is equal to root 3 into V phase. So hence KVB old is equal to root 3 into V phase. This is 127. So root 3 into 127 will give, it is nearly 219 to 19.97 kilovolts. Or it is approximately, I will take 220. Yes, 220. Now what is KVB new? MVAB new is equal to, this cannot be changed. It is 300 only as for the generator. Next, KVB new is equal to, KVB new is equal to, yes, what is KVB new here? KVB new in the sense, this is the KV of the transmission line, because on this side we are going to find out. So hence what I can say, what is this value? Here we found that, I think so. Yeah, this is that value. Yes, what is that? See this, I think it is visible to you. Yeah, KVB 231. So 230. So hence I will take, this is 230. Yeah, 230. So hence transformer 2 XTF2 old is equal to, what he has given? He said that it is 10%. Therefore, it is 0.1 only. 0.1. So hence X transformer 2 new is equal to, what is the formula we know? X transformer old, that is 0.1 into KVB old. KVB old is 220 divided by KVB new is 230 whole square, that is multiplied by MVAB new. MVAB new is 300 and MVAB old is also 300. Yeah, finally I will get 0.1 into 220 by 230 square into 1. This will be 0.09149, let it be 5. This is the per unit value of the transformer 2. So how many components we have completed? Up to this. Next, for these two I need to find. For these two, so what is the base? This 230 is the base KV of this side. But on this side I need to find. And this will be, yes, let me find out that one. Transformer 2. What are the ratings? What are the ratings? That is 300 MVA comma 127 into root 3. How we got 220 by 13.2 kV, because this secondary is delta. In the delta, phase voltage is equal to line voltage, 132 kV. So hence, what is this is HT side and this will be LT side. On the HT side, base kV is 230. On the LT side, base kV you need to find. What is the formula? Base kV, base kV base on LT side is equal to kV base on HT side multiplied by LT rating by HT rating. So here this is HT rating on kV base on HT side is 230. 230 into LT value is 13.2 divided by HT value is 220. Then how much this value? It is around 230 into 13.2 divided by 220. This is 13.8 kV. So now this 13.8 is kVB new. This is for the two motors, which is equal to 13.8. 13.8. So now the motor 1, for the motor 1, this is 1, 2, 3, 4 is over. Next, fifth one is motor 1. Motor 1. For the motor 1. So what are the old values he has given? He said that MVAB old is equal to 200. That means these values 200 comma KVB old is equal to 13.2 and XM1 old is equal to 20%, or I can also say 0.2. Okay, then what are the MVA new value? MVAB new is equal to 300. This I cannot be changed. And KVB new is equal to, as I know, this is 13.8. So finally, I can find XM1 new is equal to XM1 old that multiplied by next XM1 old that is multiplied by KVB old by KVB new whole square that multiplied by MVAB new by MVAB old, like this. And if you substitute all the values whatever we have, that is XM1 old is 0.2, that is multiplied KVB old is 13.2 by 13.8 whole square multiplied by MVAB new is equal to 300, old is 200. Then how much is this value? In the sense 0.2 into 300 by 200 into 13.2 by 13.8 whole square. This value is 0.2748. Let me take 0.2748 like this. So motor 1 is also over. Next I will find for motor 2. How I find for motor 2? already I know. This is for motor 2. Motor 2. For the motor 2 also, new values are same as motor 1. And what are the old values he has given? The old values are like this. Yes, what are the old values? That is MVA base is 100, KV base is 13.2, and XM2 old is 0.2, that is 20%. So hence XM2 new is equal to X. So here what is KVB old? KVB old is 13.2 only, and X. Yes, here KVB old is 13.2, MVA B old is 100, and here he has given XM2 old is 20, that is 20%, in the sense 0.2. That is XM2 old is equal to 0.2. So hence what is the formula? XM2 new, this will be equal to XM2 old, so which is given by 0.2, that is multiplied by KVB old. What is the KVB old? That is 13.2 divided by KVB new is 13.8 whole square multiplied by MVAB new, that is 300 divided by MVAB old is 100, like this. Then what is this value? That is 0.2 into 300 by 100, 0.6, that is multiplied by 13.2 by 13.8 whole square, so which is given by 0.54896. 0.54896, let me take 0.549 approximately. This is the per unit value of the motor 2. So now what are the values I found? The first one is generator. See here, first generator XG, what is the value I have? 0.2. And the second one I found as transformer 1 XTF1, what is this value? 0.0857. And third I found as transmission line XTL, this will be equal to 0.1815. Okay. Next, fourth I found transformer 2 XTF2 is equal to that is 0.0915 I got. And fifth one is for XM1, this I have 0.2748. And sixth one, so now recently I got this value, that is XM2 is equal to 0.549. Okay, these are the values I have. So now by seeing the problem, how I draw the reactance diagram or impedance diagram, just you see and observe. It is very simple. You will get it is very simple. You can easily draw this one. So first you see, this is the diagram that they have given. First I will take the generator. Here the single generator is there. You may have, yes. First, how to draw the impedance diagram or generator diagram in the sense. First let us we draw for generator. Yes, for generator one, how in the sense, generator reactance along with generated EMF. This is EG, EMF generated by the generator. Next, transformer. Yeah, for the transformer, this is XT1, XG, and this will be XT1. Next, transmission line. This is XTL, transmission line. Next, again I have one more element which is called transformer 2, that is XT2. And finally, the two loads are there. The two loads are, one is XM1 along with the back EMF. Back EMF EB1, and second one is also XM2, back EMF EB2. So we'll connect everything like this. Yeah, this is how I can draw the impedance diagram or reactance diagram. So this is the reactance. I can let me note like this. This is generator, and here it is one. This one is transformer 1, and here this will be transmission line, and here this is transformer 2. Next, this will be motor 1. This is motor 2, like this. And if they ask to draw the impedance diagram, this can be replaced with impedance symbol like this. This is ZTL or ZT1 or ZM, okay, or ZG, like this. Thank you for watching this video. Hope you enjoy a lot. Thank you.